Hello and welcome to Mendix World, extending Mendix with Java. My name is Alistair, and I'm on the Evangelist team here at Mendix. I've done Mendix for a long time, but I come from a technical background, and so one of the first languages that I fell in love with was Java. And so it brings me great pleasure to talk to you today about Java actions. What we'll cover today is what Java actions are and what they look like today, how you can use Java actions in your environment with some of your favorite IDEs, as well as all of the libraries that you need to get things done. And lastly, we'll have a look at how you can extend and reuse your Java actions simply throughout your organization. In software today, it's very rare we find ourselves reinventing the wheel when it comes to enhancing the capabilities of our apps. There are so many businesses out there that are solving common problems that software faces in all technologies. And what's more impressive is the open source community, which has massive ecosystems that support businesses solving problems for a potentially much lower cost. And when it comes to integrating with these services and this data, it's not always the case that SOAP and REST services are the best way to go. Perhaps the service just simply doesn't exist. Or there might be a performance implication to take into account when it comes to point-to-point response time and latency. Of course, there's the security consideration to be made when it comes to reducing the number of calls that are made outside of your network. And the reason might be as simple as the fact that the client library code is written in language that is familiar with your team, and therefore will be faster to implement and easier to maintain. When it comes to implementing client library code and SDKs in Mendix, this is done through Java actions. Java actions exist within your Mendix project and allow you to extend your Mendix application through custom Java code. And in fact, because Mendix's runtime is based on the JVM or Java Virtual Machine, it's possible to import libraries that are compiled in other JVM languages like Scala and used within your Mendix application. Now, before we jump into the demo, I'd like to say that if you missed anything along the way, all of the project files that we will be using in this project will be available after the presentation, so don't panic. Now, before we jump into code, we have a problem to solve. Let's say that we are an online travel agency, and we provide functionality for our customers to upload photographs along with their reviews of travel services, such as hotels, car rental, or tour guides. Now, with this example, and with many others like it, there's a common problem. In the digital world today, privacy is extremely important, and it is critical for us to protect our customers' privacy and their personal information. So one interesting way of doing this, in our case, for the example of uploading photographs to the platform, we would like that whenever a photograph is uploaded by a customer, and if there was a face, either on purpose or by mistake, included in the photograph, we would like for that face to be automatically detected and blurred out so that the privacy of that customer can be protected, as well as the privacy of others. We are going to solve this problem by using two Java actions. The first Java action will be to detect faces within a photo, and for this we will use Google's computer vision client library API. The face that will be detected will come in the form of an X and Y point, which will indicate the beginning of the box where the face is located, as well as a width and height, which will indicate how large the box where the face is contained in is. Now, the second Java action will make use of these face locations in order to blur them out inside the image or photograph. So let's jump into it. Here we are in Studio Pro with a mostly clean project. All we have is a photo entity which inherits from the system image, which allows us to upload photographs. We also have a credentials entity which inherits from the file document, and this allows us to upload the credential files that are required to integrate with Google's vision. What we also have is a simple page that allows us to upload photographs. Now, in order to store the face locations, we're going to create a non-persistent entity because we're only going to use this information temporarily. We'll name it face location, and this will contain all of the attributes that we need for the face, which will be the X and Y points, and the width and height, which indicate how large the face box will be. Now once the entity is created, we can start looking at how we create our Java actions. So I'll start by creating a new Java action. And we'll use a naming convention, JA, to indicate that it's a Java action. And we'll call it detect faces. Now when creating Java actions, we can add any number of parameters to pass through into the Java code. And these parameters can be of simple string types or numbers, but they can also be of complex object types. And these complex object types can be represented by the Mendix objects that exist in the Mendix domain model that we have created. So in our example, we will be using a source image, which will be the photo that we pass through to search for faces. And this will be of type photo that we created earlier. Next, we'll need to pass through the credentials file, which will be used to authenticate with the Google Vision API. And this will be object of type credentials, which we also created earlier. And lastly, of course, we want to pass back a list of all the faces that we have detected inside the photograph. So for the return type, we select that it'll be a list, and we determine that the type of the list will be the face location, which is the non-persistent entity that we created earlier. Now, before we jump into any code, we need to make sure that all of the libraries that we need in order to integrate with Google's Vision API are inside our project and ready to go. So for this, Mendix allows the use of automated dependency management by using tools that enable dependency management such as Maven and Ivy. And so for our example, we're going to use Ivy. If we have a look at the ivy.xml file, we can see it's configured with a list of dependencies that we need in order to integrate with Google Cloud's Vision. So all that I need to do in this case is to make sure that I'm inside the correct project directory, which is our project, and then I'll need to run the Ivy command, which will take this configuration file and look for all of the libraries that I need inside my project based on the Google Vision requirement. And now it will start loading the libraries and including all of the jar files that we need in order to achieve this functionality. And once it's complete, it will let me know the status of the project and whether all the libraries have been copied in correctly or not. And of course, if the libraries already exist, it will not remove them or have an issue. It will just let me know that they haven't been touched. So now all the libraries have been included in our project, and this will allow us to carry on from here. Now we need somewhere to edit the Java code. So in Mendix, projects are deployed in such a way that they allow you to use popular Java IDEs such as Eclipse, IntelliJ, JetBrains, and NetBeans. So if we open Eclipse, we can import our project into Eclipse using an existing project. All that I need to do is to make sure that the correct project folder is selected with all of my project files in it, and click Finish. Now all the Java that I need at my fingertips is available. Once I've found my new Java action and opened it, we'll see immediately that Mendix has created some boilerplate Java code. So what it has done is wrapped the action in a class. It's also included all of the parameters that I've selected in the model to be passed into the Java. And it's also provided an execute action method for where I'm to implement all the code. So here we will implement a simple method for integrating with Google Cloud Vision. Now the next thing to do is to make sure that all of the imports are correct for the classes that I need. Now that we've done this, we can start to look at the code. So the first thing we're doing is setting up the credentials for Google Vision. Next thing we do is convert the photo into a format that's usable for Google Vision. And we set the feature type to facial detection. And then we prepare the request for the API. Once the request has been sent, the response is in a list. And the response that we're interested in is a list of faces that have come back from the Google API. So we iterate through each of these faces, and for each one we access what's called the bounding poly, which is the box where the face is located. And so we can use this to get the X and Y that we mentioned, as well as the width and height, to determine the size of the box. Now we want to get this information back into Mendix to use in our next Java action. So Mendix also creates, to map to each Mendix object that was created in the domain model, a proxy Java class, which contains a constructor and setter and getter methods for each of the attributes that are contained in the entity. And this allows us to create and interact with objects in the Mendix domain model. So for our example, I'll use the constructor to create a new face location, and I'll use the set methods to set all the attributes that we need to pass back. And the last thing that I'll do is once the face location is created, I'll add it to the array list that we created of face locations and pass this back to Mendix. We'll also see inside this Java action that there is a slot that's been given for extra code. And this can be used to write any private classes you need to run inside this Java action, or any additional methods to make your code more readable. So in our case, we'll implement a credential provider class that's required to authenticate with Google. Now that we've created our Java action that will detect faces, let's have a look at our next Java action, or let's have a look at blurring images. When it comes to the digital space, images are stored in an array of pixels. And the act of blurring an image is the simple task of taking a pixel that exists in an area that you would like to blur and mixing and merging it with the pixels that directly surround it. So let's have a look at our new Java action. We'll create a new Java action, and we'll use the same naming standard, but this one will be called blur boxes. When it comes to the parameters for this action, the first parameter is going to be the source image, which will be the photo that we added before. Now in our example, we said that we plan to replace the original image with a new blurred image. But if we're really going to make this Java action so that it's reusable throughout our organization, there's a use case where we will need to add a destination image as well, which will allow us to retain the original image. So I'm going to add a destination image too. And this will be of the same type. Now the last parameter we'll need is, of course, the list of face locations that we detected using Google Vision. So I'll add the list, and I'll specify the type being the face location, which we created earlier in the domain model. Now finally, for the return value, we're going to keep it simple and just return a Boolean value, which tells us whether the action was successful or not. Now we can rerun to see our new Java action displayed in Eclipse. And so if we refresh the folder, we should shortly see our new Java action. So let's open it and have a look. So this one has been created much the same as the others, except the parameters are slightly different. So now we'll implement a simple piece of code which will allow us to blur images based on boxes. And again, we'll just make sure that the inputs are correct. Once that's done, we can start to look at our Java action. So in addition to proxy classes for all the objects in Mendix, Mendix also generates a load of helper classes and methods which allow us to integrate with features of the platform. So in this case, we make use of a core function called getFileDocumentContent, which allows us to store the source image inside a file input stream, which can then be used later for image processing. The next step is to determine what is called a convolution matrix, which is used to do a blurring filter. Once that's created, we can then iterate through each of the face locations that we have received in the parameter list. And we use the dimensions that we received to create a sub-image of the photo. And in the last step, we apply the blur filter that we've created earlier to that sub-image. Once the loop is complete and all the faces are processed, the next step is to write the new image to the destination parameter that we specified earlier. And before we do anything else, we make sure to clean up any streams that we used and of course return true if everything was successful. Now that we've done all the hard work, it's time to put our Java actions into work. So we already have a microflow here that will be used to process our image. The input parameter will be a photo that we have already uploaded. And the first action is to retrieve a credential from the database, which will allow us to integrate with the Google Cloud API. So the only thing that's left to do is to integrate our Java actions. The first Java action we're going to use is to detect faces. So we drag that action on and configure the parameters. And the source image will be the photo, and the credentials file will be the credential file that we just received from the database. The last thing to do is to add a nice name for the output parameter, which are the list of face locations we get from Google. Next, we can use our blur action. So we drag that on afterwards. For the parameters, the source image will be the photo, and as we said before, we're going to replace the original with the new blurred photo. So the destination photo will be the same. And lastly, as the input parameter, we select the list of locations that we got from Google. After we've set a nice name for our return value, our microflow is complete. Now, before we have a look at our results, let's talk a little bit about how we can package and reuse our Java actions. At the moment, if we have a look at this microflow, the Java actions look a bit ugly and a bit generic. And in reality, if someone else were to use them, they would be very difficult to find and they wouldn't be categorized. So what we're going to do is we're going to expose our Java actions as microflow action activities, which will allow us to add icons and categorize them into groups. So if we open one of our Java actions and expose it as a microflow action, we'll notice the first thing we can do is give it a nice name. So we can call it detect faces in image, which is a little more intuitive. Next, we can categorize it. So in this case, it'll be under computer vision. And we can go one step further. We can add an icon, which allows to show for familiar brand names and functionality. For example, we'll use the Google Cloud Vision API icon. And so we can do the same with the blur boxes. So we'll expose it as a microflow action. We can improve the caption to say that it will blur boxes in an image. And now we can categorize this one as image processing. And lastly, we add an icon to represent that it will be a blur effect. So if we go back and have a look at our microphone now, we can see there's a big difference. Now, anyone who is using or implementing this microflow or these Java actions can clearly see what the purpose is of them. And what's also been done is it is much easier to find them. So if we have a look at how we would find a Java action again, we'd have to select Java action, and we'd have to search for it in the right module. But when it comes to these Java actions, all we need to do is search under the correct category. So under here you can see we now have a computer vision category, and we can use the detect faces action. The same under image processing for the blur box. So this makes it a lot easier on your colleagues for when they are reusing Java actions within the organization. And they don't even need to know that it's written in Java. All they need to know is how it works and where they can use it. So let's have a look at our results. Here we can see we have an example of a customer photo that's been uploaded with a review. And this is a great photo of a hotel room which contains the bed and the cupboard. But the problem is it has a face in it. So let's see what happens when we try to blur the face using our Java action. This image will be sent to Google's API. The faces will come back, and then our Java action that will blur the boxes will attempt to blur them inside the image. Okay, it's complete. Let's have a look. And now we can see our photo has now become anonymous. The personal information of our customer, or perhaps that of a bystander, is now protected. But what happens if there's more than one face in the photo? Let's see what happens when we apply our blur to this image. Again, the image will be sent to Google's API, the face is detected, and their locations will be sent into our blur action. Now you can see the photos have been blurred, so the privacy of these people have also been protected. Now I have very much enjoyed creating these Java actions, and if you feel like you've missed something or if you want to take part, all of the project files that are available that we've used today are available on my GitHub at Mendix Crawford. And if you're wondering what other things you can do in Java, we've seen customers implement custom documentation generation with PDFs or with Word documents. We've seen custom implementations of single sign-on, as well as custom request handlers, and many, many more. So I extend a challenge to you to go and have fun with Java and Mendix, and go make it.